We'd like to demonstrate how to solve a differential equation and plot it. You can also add an IVP. We'll also demonstrate how to solve interactively and return a solution. So there's two primary approaches. One is to go ahead and just simply make use of the right click. We press enter. Here is the differential equation. If we're looking for a general solution, like we are in number 4, then we would simply solve this by right-clicking and say solve DE for y of x. We get a family of curves for different constants. The C1, of course, represents different constants. It's in a bit of an ugly form. If we would square both sides, we would have y squared equals x squared plus some constant. Let's go ahead and copy and paste that. And to simplify it, let's take out the y of x and just call it y, and also call this some constant c. It's true that we could square both sides. Maple doesn't usually offer that with the highlight and hover. So if we simply manually do that, we'd have y squared equals x squared plus a constant. We can highlight the x squared. It will offer, do you want to subtract it from the other side? And we want to do that. We have the family of hyperbolas. You can copy and paste this. Again, this represents a family of curves. So if we put different constants in here, we will get a variety of graphs. Press enter, right click, plot, and whoop, I must not have pressed enter. No, I'm missing one. There we go. Right click, plots, 2D implicit plot xy. We see hyperbolas. If we wish to solve with an IVP, process is slightly different. We can go back here and press enter and right click on that differential equation, and notice it offers add an initial condition. So now we're going to solve for a specific curve, and that's the one that goes through 0, -3. So we type that in under the add additional condition. Click OK. Now we're looking for the function that satisfies both of these conditions. It satisfies this differential equation. It also goes through this point. Now when we solve, right click, solve DE, it gives us a specific solution, the one with the constant of 9. We can highlight that and right click and say plot. Notice that it only gives us the bottom half. We would need to change our axes. In fact, probably want to square both sides again to get the rest of the curve. So that's the fast way to solve. Just right click, add the additional condition, and solve DE. Another approach is to solve interactively. So if we go back up here and right click, it offers solve interactively. When we right click, a pop-up window opens, and it does not list the initial condition right here. If we click on edit, we can add at 0. The value is -3. Click on add and click on done, and it puts in that we have two requirements. The function has to satisfy this differential equation, and this is the initial condition. If we click on solve numerically, it applies numerical methods to get the function's graph. If we click on solve symbolically, if it's able to solve it, we click on this and it gives us the specific curve. And if we click on plot, it gives us that plot. It's a little bit restricted in how you can vary this. If you click on plot options, you cannot change the window. It's true that sometimes you'll get a constant, and down here you can put the constant in place of the C1. If we didn't have the constant entered with the IVP, it would offer a C1. When we click here, it offers, we could either return a solution or a plot. If we wanted the graph, we could click on plot, click on quit, and it would insert the graph. If you go back, it's quick enough to do that. And again, it doesn't have the initial condition. We could add the initial condition again, but let's just click on solve symbolically. If I click on solve, it offers the solution but with different constants. You're going to find that when it finds these two different solutions, it does not want to plot that. So you would need to have the initial condition in for this particular one.